All right, so we are back with two fan favorites over here. Everyone should recognize Russ from his familiar background, but this is a new background for Elliot. He decided it was enough taking the podcast indoors. Now we're taking it up from the farm. So thank you both for coming back on.
Thanks, Adrian. I actually got kicked out of my office, so I'm sitting outside.
So he seems happy, but it was not willing. So topic of conversation today. This is very relevant because it seems like it's become a daily conversation. Is the state of the industry and how price sensitive and price driven everything has become. And it seems like that impact and effect is sort of further becoming exasperated, whatever you want to say, over month or over time. It just seems to be getting worse. And I think us on this call who are very familiar to our local New York market have been very accustomed to this, but I'm hearing and finding that in other markets, they are really feeling that effect, and people are willing to do things they might have not been willing to do in the past and test out new systems, new contractors, new means and methods. So I guess I sort of want to open up the conversation to say the industry is becoming more educated and aware of certain things more and more so over time, yet we have this sort of counteracting theme occurring in the industry that I don't know what the long-term impacts will ultimately be. So I guess I'll start by asking, what are you guys seeing, and are these conversations that are being had behind closed doors?
You want to start, Elliot?
Sure.
Okay.
Yes, we're seeing it a lot. A large part of our business is investigative work. So we come in afterwards, and it's amazing how many jobs we get calls on, which we bid during the construction phase and lost, and then get called back when there's a problem. And you start to trace things back, and you say, okay, this was a design issue, this was an installation issue, this was quality control, a lack of quality control. And unfortunately, they're all about equal right now. Part of that, and I've talked about this before, is we just haven't caught up to the changes in construction materials. We build, I like to say, lighter buildings today, especially lighter walls. And when done correctly, they can be great and last a long time, but we haven't developed that tribal knowledge yet on how to do it correctly. And so we have to work on that. As far as what I think will happen, I think like everything else, just like the stock market, it eventually corrects itself. So there'll be enough problems where people will start bouncing back the other way. And maybe not everyone, but you'll get the smarter owner developers, the smarter GCs all starting to say, we can't take a chance on that. We're not willing to go overseas unless we know it's a great company that has done projects here before. And that'll start happening. It'll be the bounce back.
Not only, Russ, what you're seeing from, I don't want to speak from the contractor and supplier standpoint, but more on the soft cost side of things when it comes to facade consultants or engineers, the engineer of record. Are you seeing a lot of pressure on that end, and owners or end users really just trying to get the minimum baseline requirement to either meet code or just get them over the hump that they need?
Well, I guess I should start out by saying the way we look at it is that you pay now or you pay later. And usually the cost later is much, much higher. If not in dollars, it's in time. It's in the process of unraveling whatever mistake or whatever oversight or whatever economic decision was made earlier on that has left a project vulnerable. And so what we see is in cases where there's an attempt to produce a project, whether it's a curtain wall project or whether it's even a custom project, if you don't put in the work at the beginning, if you don't use the experience that is available to practice very similar, same principles, first principles that are used on all good projects, if you shortcut, there can be consequences. And that's the difference, I think, that's what we see economically between paying now or paying later. You need reliable consultants. You need reliable fabricators. You need reliable confirmation tools, such as testing. And the proof, since we're using phrases like this, the proof is typically in the pudding. And very often, if testing shows that there's some sort of system-wide problem, you have to look at the reason why that problem came about. It may not be immediately obvious that it's a technical problem. It could have been a problem that came about from an economic problem. And so, generally speaking, we find that that when there is a really tight squeeze at the beginning of a project, either from a consulting side or from an engineer of record side, the risks make themselves known in one way, but they don't show their true nature until later. And we try to work around that. We try to avoid that. We try to recommend to our clients what to do. We give them a list of risks and solutions. And we make sure that they have the opportunity to make a decision to either pay now or pay later. And that's the way we like to go about it anyways.
Sometimes I feel like the service at hand is just not properly or effectively communicated to the end user. So they might just see, okay, the testing lab scope is, contract is $160,000 for this many tests at this duration, and I want to go with the guy that's $110,000 instead. But they don't realize, like, well, maybe you can cut the number of tests by 30 to 40%, but if you test the right areas at the right time, you're going to diagnose and address certain issues that will save you so much money and headache down the line. So it's almost like, are we spending the right amount of money in the right areas where we'll have the greatest impact?
Yeah, that makes a lot of sense. And it's, again, the advice of experts that give owners the opportunity to make choices. Does a mock-up benefit from being gunned full of silicone between a failure and a success? And what does that mean down the line when a building facade requires so much silicone gunned into joints that may not survive as well as the rest of the system? These are sort of short-term decisions that have long-term implications. I'm sure Elliot has something to say about that too.
Yeah, you and I were talking about this the other day, how important mock-ups are, and they're getting VE'd out a lot. And the mock-up is the baseline, right? It's not just the baseline for the performance, but it's how coordination on the job site happens. I talk about this a lot, that today, curtain wall and window wall in the major cities is still a big part of the market, but punched windows in rain screen style openings are really starting to take over and become the majority of the projects. Now, if you have a curtain wall or a window wall, it's one contractor, one supplier responsible for basically 90% of the wall. But when you start getting into a light gauge framed wall with uh, uh, sheathing like dense glass or any other gypsum sheathing or wood sheathing that's going to get waterproof, then you're going to have brackets to hold on whatever your finished rain screen siding is on the outside. Trims, how it interacts with windows. We still see through wall HVAC units like PTAC. So all this stuff requires a tremendous level of coordination that honestly doesn't happen on the job site because the sequence of operations isn't that well understood most of the time. And we work that out here at the mock-up stage. It's more than just performance levels. It's how are we going to build that building correctly? We have one in the shop right now. It's got a major assembly for a dropped lintel. So the lintel is 2 feet below the slab, right? And with today's, concentration on thermal bridging, how this drop lintel was done and how it was insulated and how the waterproofing worked took 6 weeks to work out in my shop. Now, the project's just going on now, and the mock-up was started back last, I don't know, August, September, but it was, critical to having a successful project. And we were lucky that we had a good owner, a good contractor, and good subcontractors that realized this, but doesn't always happen.
I know what Elliot's stance is going to be, so I want to defer to Russ for a second and ask, do you think the testing protocols that we follow, whether it's a mock-up or on-site chamber testing, are realistic, or do you think at times we're not exactly being practical to true real-life conditions?
That's a great question because recently we were testing, we were involved in testing and remediating steel windows. And steel windows have different requirements than aluminum windows. They're the same barrier that aluminum windows are, but for some reason they have different testing requirements. And I think it has something to do not with physics and the environment, but more to do with the steel versus aluminum. I do think that there are effective tests, and I think years and years have of experience with good experts and good agencies has produced, in some cases, very good mock-up testing sequences that really do give a realistic, um, uh, if not conservative, reasonable testing of a system under extreme circumstances. At the same time, we get involved in projects that require very specific testing because of, say, a peculiar geometry or a particular material configuration. And in those cases, I think we've seen that writing bespoke mock-up sequencing and testing protocols makes a big difference. We were involved in a project that involved glass, marble, glass, and a laminated assembly. And the testing requirements for the durability of that were very important. I think that the standard tests are a useful reference, but I think it's very important to look at the particular project requirements and to not just put a generic set of testing requirements on a specific project when that project is screaming for something more. That could be an economic decision too, since we're talking about this couched in economic decisions.
Yeah, and sometimes it's for peace of mind. Like Russell was just mentioning, the one with the glass laminated units. That one we did some custom test, very custom testing on that we had to develop, just because we found some, I don't want to say defects in the glass assemblies, but we had some issues with or the owner had some issues with the glass assemblies and wanted the peace of mind to know that it was going to work. And we developed a custom protocol, custom test for that, and it was, I think, successful. The building is up and functioning well. It's a beautiful building, but it's always different. I think what people lose sight of is we swap meteorological units for engineering units, right? What I mean by that is it's all about the wind. The wind drives so much of the testing, right? The water test pressure is X% of the wind. The wind, the wind load creates the structural test requirements. It's all about the wind, and people forget that. You know, let's look at the wind at the area first. Let's really look at it. If the prescriptive number seems too high or too low, let's work to not just take a canned specification out of a hard drive and plop it into a job, right? We need to look at the building and say, well, it's only a 5-story building. Sure, it's here, but is 70 PSF really required? 70 PSF is a very high wind load. We consider it a hurricane. And is it really necessary to do that? And one of the issues we have is once it's a construction document, it's a lot to go back on that, right? Everyone is very resistant to saying, well, we know it says 12 PSF test in the specifications, but it's a wood window that doesn't really ever get tested to 12 PSF, and we're dealing with it now on 3 or 4 different jobs, where it's just a legacy specification that really wasn't checked well enough prior to releasing the documents. And now everybody's afraid to go back on it because if there's a lawsuit, I'll get sued because there's a leak now. I got news for you guys. Most of the time, the leaks are not happening on a 72-mile-an-hour wind-driven rain. They're happening on a normal rain. You know, that's when we go investigate leaks. Sure, it's worse when the storms are bad, but how many times a decade do we get in New York, in Philly, in Chicago, a 72-mile-an-hour wind-driven rain that sustains for 15 minutes? We don't. But the chamber test is not to duplicate a storm. None of those chamber tests are actually meant to duplicate a storm. They're meant to test the assembly. They're meant to test the seals, the gaskets, the joinery. They're meant to make sure that they were field assembled correctly, the seals were done correctly. It's to make sure that the product is survivable, meaning not that it's going to withstand a storm or two, that it's going to be serviceable for a normal lifespan of 10 to 20 years. So it really is a serviceability test more than and thus a torture test. And I will admit the tests are torture tests, but they're torture tests for reasons. We don't want it to survive 2 years of storms. We want it to survive 20 years of storms. And that means we have to overstress it to make sure it's going to be a long lasting product.
For all your career experience, have you found that New York, focus on the glazing assembly for 1 second, New York requires the most amount of customization than any other market? Meaning, I wouldn't say we're more sophisticated, or it's not what I'm getting at, but it feels as though the demands and requirements to keep up with all the different configurations and sizes and profiles and everything they're looking for on the project has become more demanding in New York than any other market I've seen in the country. So I guess before I ask the next question, is that something we're in consensus on?
I would say that there are lots of different permutations of standard systems on New York projects. And in that sense, I think there can be a lot of demand and changing demands based on configurations that are not straight out of the book, let's say. And I don't mean to change the subject completely, but what Eliot was talking about makes me think about the benefit of, from an economic point of view, reviewing contract documents and making sure that contract documents are sensible before tenders are signed. I can't emphasize how beneficial it is to have a reliable consultant look at a set of project documents and pick out those pitfalls, those problems, those 12 PSF tests on a wood window sorts of things that become legacy problems for a project. I have another example of how consultants can be very, very useful on the design side, whether it's working for an architect or working from a fabricator. But I just want to make sure that we acknowledge what Eliot was getting to from a consulting side and prior to projects being tendered.
Agreed, but what happens when a consultant develops the specs, an owner buys out the project and buys out the project from a contractor or fabricator that cannot meet certain spec requirements?
That's very interesting. These are the sorts of things that need to be flagged. It may be the case that those suppliers get taken out. They're no longer allowed to participate, or it may be the case that these people are actually indicating something that's truly problematic that the owner really needs to pay attention to. I can think of all sorts of examples, pitfalls and problems that really should be paid strict attention to before, again, a contract is signed. If a fabricator who's putting their best foot forward is making a statement about a problem in the project requirements, I can think of a good example, concrete tolerances. Not to pick anybody out, but concrete tolerances can make a huge, huge difference to many different systems. Window wall systems, for example, how they deal with concrete tolerances can be very, very difficult. You have to understand and anticipate. If a supplier calls something out in the project tender process, I think it's something that an owner would be beneficial. It would be beneficial for an owner to read into it, find out what it's really about.
Well, Eliot, I'll give you a perfect example. We're talking about if a contractor, GC or owner onboards a subcontractor that's not capable of meeting certain spec requirements. So I'm looking at a job right now where a facade consultant that you know very well wants us to seal over the polyimide thermal break at the sill. And we'll come back and say it's going to be more money, it's going to be more factory labor. Here's all your test reports and everything showing that we can meet the tests, and I guess there's no way of proving long-term durability, but showcases of how many times we haven't had to seal over the thermal break. So it almost, I don't want to say becomes like a finger-pointing battle, but actually getting over that hump as to what's being bought and what they're going to move forward with, it kind of falls in the lap of the owner, right? You might be on mute. Yeah, people will laugh at him not realizing it's his 6th podcast and he's still trying to figure it out.
Oh, not yet.
But in the meantime, yeah, that becomes a huge battle because there's a time crunch. You have a couple weeks to be released, and the spec says this. We didn't agree upon this. This conversation was had behind closed doors, and yeah, that's I don't think enough time is spent not only on the development of specs, but also it's everybody's job to review and flag and call out items before that final decision is made.
I agree completely. How many projects have we seen where a window fabricator has analyzed the aluminum profile that's required for a project with a thermal break, not accounting for the properties of the thermal break and the semi-composite behavior of a profile? I can't tell you how many times we've run into that. It's a real problem because once you realize that a thermal break has a different elasticity, a different strength, a different engagement than a solid aluminum profile, it becomes a very, very disappointing exercise to actually determine the performance and then realize what needs to be done. So I think all of this stuff needs to be put on the table before a contract is signed. I think everybody needs to make educated decisions, and you're absolutely right, Adrian. It goes right back up to the owner. The owner is the one who holds the bag. And I think the owner needs to be given the information to make a decision as soon as possible, obviously before a contract is signed, and certainly before a system's installed.
Yeah.
Adrian, there's another example, and it covers some of the things we talked about in a previous podcast. Nickel sulfide. My goodness. I mean, how many times do we recommend a heat soak and the owner says they don't want to pay for it? And God bless them. I understand the reason why. We know that there are certain window fabricators who will heat soak automatically because they just simply don't want to deal with the problems. If they're producing hundreds of thousands of square feet for a project, if one panel pops, they don't know. And so this is the sort of thing that I think would need to be brought to an owner's attention as part of the bidding process. Do you want to pay for a heat soak, or do you want to design for heat strengthened glass instead of fully tempered glass? All of that stuff weighs in.
One thing I've been listening to overhearing and listening to a lot of conversations about is glass standards and expectations in terms of what will and will not be accepted, maybe in terms of physical blemishes or imperfections. And you can imagine a window or curtain wall or window wall manufacturer receives the units and they do their own, you hope, internal QA/QC before they structurally glaze and assemble the units and then send them on site. But units might arrive on site and then an architect, facade consultant, or owner might say, what the hell is that? Or that's not acceptable, or we're not going to throw that on our building. So getting into consensus about what will and will not be accepted. But I don't know. I mean, what a liability. And a lot of times maybe the glass supplier will replace it under warranty, but what about all that additional field labor? Who's responsible for that? And so it becomes this massive, massive, massive finger pointing battle. And so glass specs, ASTM specs in terms of what will and will not be approved. And then an owner might say, I don't want to pay for that, or an 8mm scratch is okay, but a 12 is not this. And how far back are you standing? And is it visible on the street side, but not on this side? So yeah, it's and that goes back to the spec.
It does. It does. It goes back to whatever the standards are that are referenced, whether they're in the case of visual quality of architectural glass, whether it's an American standard or whether it's a European standard. And I think we talked before about European standards being perhaps very, very useful. How many times have we seen that where roller wave becomes a problem, or refraction and iridescence on fully tempered glass? These sorts of things need to be vetted. Again, it's not only part of the process of vetting the product before it leaves the factory, but also part of the specification review at the beginning of the project. Recommendations like that from fabricators are very, very important to consider.
Definitely.
I brought up New York, and this is where I want to come back to that initial comment and ask Eliot about this, because assuming that New York demands new system types, testing the limit, and all these various forms of experimentation in the means of facades, if you think about the importance in that case of implementing a performance mockup or enforcing QA/QC within the fabricator's plant before they send it out to the job site. I can't tell you how many times we make a modification to our system or a slight this or that. All of a sudden, we throw it in the test chamber and it fails. So it's like if you don't do that investigative work internally, aside from an independent lab, when you start making these minor tweaks and changes to the systems. I mean, you've probably seen this, Russ, as well. Oh, we'll get rid of this gasket at the corner or this foam block, or we don't need weeps here, or add in. All of a sudden, you start making minor tweaks and changes to these systems, and it completely changes the game. So here, if you have owners demanding some form of customization to the system to make their architect happy, but then they want to VE out the mock-up, you're basically setting yourself up for failure on site.
Definitely, definitely. And sometimes it's not even as complicated as bleeding gaskets. Sometimes it's just changing a supplier, right? You assume that they're all equal, and then you find out, oh, their locking points weren't the same as the ones we've been using for the last 20 years. And yeah, what I would say, we see a lot of customization on lots of projects outside of New York. It's not just New York and Chicago and LA. We see a lot of customization. You see it here on more, I don't want to use the term pedestrian jobs, but the mass market, multifamily, multi-story, high-rise market gets a lot of customization here. And it's not, and we see it as representing, I don't want to say a whim, but yeah, a lot of times it's somebody's design element that they don't realize the impact it has on the project, on the schedule, because what seems like a simple change that they didn't uh, check with the manufacturer on whether or not it was that simple can cause you to have lots of problems. Like you said, you get in the lab and start testing it and you figure out it's giving us other problems. The drainage path of the system has changed now and it's not draining correctly or it's not draining fast enough from a small change. So it's real important to really consult with manufacturers when you make a change and ask them, is this going to require us to test the whole system over again? Or is it a small enough change that it's not going to affect your previous tests? And that's a big one.
This a project the three of us worked on, 200 Amsterdam, which Elliot posted about the other day. I was an inspector at the time on that job, and I really had to learn from scratch. It was a hybrid window wall system, which I didn't have a high level of familiarity with. So I was learning about all the various components and what was doing what. And I mean, it was a complex system, so there were a lot of different components. And I remember doing some inspections for the operable windows, which were taller awning units, and seeing all these corner joinery seals and cap seals on this fastener, but not on that one, and a foam block there, and a keeper there, and there's a seal there. And it was a lot happening and a lot that you can't just design a system like that on paper and say, okay, that's going to pass. It's like until you throw it either in a chamber in their shop or put your chamber up in the field, nobody knows. It really is a discovery phase.
It is, and AMA just published the latest version of AMA 501, which is the mock-up specification, right? So literally last week it was published, and I was vice chair of that task group that was responsible for updating the document. And one of the things that I was pushing for, and I think some of the language made it in, was listing R&D testing. So do you want to give a manufacturer the opportunity to do R&D testing in their facility, in a lab, anywhere prior to a mock-up? Because I think that's important, right? If it's a totally new system, before you hit the mock-up chamber, you really should be doing other tests, and the manufacturers know them better than anyone because they're trying to figure out, hey, is this stack joint going to work? Is this mullion? We draw things today in 3D. That doesn't mean it works. I've got news for you. Till you either print samples of everything on a 3D printer or run the extrusions and start machining them and putting them together, you don't know 100% that it's going to work. I don't care what software you use. I don't care how many times you render it, rotate it, zoom in on it. Until you put that thing together, nothing for sure.
We're all smiling for a reason. We recently investigated a project where a system was available within roughly 500 pages of an installation manual for all different permutations of a particular system. When we investigated the system, we were given this 500-page manual, and we went through the 500-page manual, and we couldn't find the configuration. And we found out that what we were looking at was an improvisation, something that was not within the manual. And we went through the process of investigating it, remediating it, making it work. And then we were contacted by the manufacturer and asked us what we did so they could incorporate it into the manual. And I think that's a success. You know, we were very helpful in our owner client successfully completing their project with a window that maybe nobody will ever know was an improvisation. But it's the sort of thing that I think comes as a result of the economic decisions, and then perhaps the lack of opportunity within the project schedule, or even an understanding between the various parties that R&D is worthwhile, that having the right experts on the project is worthwhile, paying now versus paying later is worthwhile, all of those sorts of things, back to our main theme.
How much of it would you attribute to design fabrication related errors versus installation errors?
In our local market, I'm seeing 50-50. Seeing 50-50. We're seeing a lot of imports from all over the world, Europe, Asia, everywhere. We're seeing people bringing product in, and they're using usually a good quality, internationally known system provider, but a fabricator that may or may not be qualified to do the type of job that they've awarded to them is doing the actual fabrication. And I know that the big guys, the Shukos, the Wakonas, they're all giving people excellent engineering support, but there's a limit to that just because of reality, right? You just don't have time to wait for a process to happen lots of time and submit something to an engineering department. They look at it, it comes back, 3 weeks go by. You don't have those 3 weeks lots of times when you're on a deadline for a project. So things just get done that really weren't approved by the system manufacturer just because the schedules are what they are, and we find that that leads to a lot of issues on jobs. And then we're losing. I mean, we just lost Warsaw this year. Apogee announced no more Warsaw, which to people like Russ and me is amazing to even think of, right? And if old guys like us start thinking back on the awesome companies that we've lost in the last 20 years, the brain power that was at these companies that was lost, it's scary because lots of the customization used to happen because people had experience. People had done something similar. Remember what the problems were that they went through, how they worked it out. Today, a lot of people are just making assumptions about things. And, again, we're very reliant on software, whether it's finite element analysis or just 3D design software. And we think we've got it all down. But again, until you extrude it, cut it, screw it together, glaze it, stack it, spray water on it, it's still a mystery, right? You still don't know. So
I asked about the design versus the installation because I don't know if you find a major disconnect between the supplier and the installer. In the cases you were just describing, it's even a further step removed where you just have a system designer to a fabricator to an installer. But how many projects have you been on where you see carpenters shoving a 2x4 into an operable window, or putting in terrace doors before they do their roofing and pavers, and putting the pavers above the drainage paths? So all these things which are just like rinse and repeat problems. So you could say it's a 50-50 issue, but maybe the bigger issue at hand is you don't actually have the suppliers or manufacturers working closely with the construction team. having eyes on the site to ensure these problems don't come up.
We see that. We definitely see that. We've seen projects where anchors that need to be installed in a formwork are installed by the concrete or the formwork contractor, and that formwork contractor knows nothing about or perhaps hasn't been communicated properly from the enclosure system provider, and whatever was written in the spec is just simply missed. Anchors go in however they can be put in, whether there was any knowledge or not, and the coordination is a missed opportunity. It's a missed opportunity that can create problems. So yes, we see that a lot, and we think effective consultants will step in. You know, really useful consultants will not be there to make everybody do extra work, but will be there to show that the work that is required is not extra, but is utterly essential.
So in that case that you just mentioned, Russ, how many owners know to buy those embed inspections from the facade guy? It's getting thrown into the concrete inspector's package, and they're not looking at it from a facade inspector's viewpoint, right? And this is a problem, and I like to say the road to hell is paved with good intentions, because in order to increase the level of inspections and testing, when we adopted the ICC throughout the country, not just New York, we made special inspections and periodic inspections mandatory. Well, as soon as it became mandatory too quickly, right? Because we didn't have a real good infrastructure of how inspectors and people who supervise inspectors need to be trained and qualified to look at what look at what they're inspecting.
You brought this up, I think, on the phone to me last week, Elliot. We're talking about on-site testing, on-site inspections, but what about the inspections in the fabrication facility, either in the float glass or IGU fabricator's plant or in the unitizer's plant, who's actually watching the structural silicone glazing or the deglazing or the butterfly tests or the adhesion tests or all of that? Is any of that actually happening?
Some, but not enough. And I think so. We're in New York. We're working on this right now. We're in the middle of the review of Chapter 17, which is the testing and inspection chapter of the New York City Building Code. But it's also the same in the international code. Chapter 17 throughout the US is the testing and inspection chapter of the building code. So right now we're looking at what we call approved fabricators, right? And we're looking at the language there. And till now, at least in New York, that's meant precast manufacturers, steel fabricators, and modular construction companies. So we looked at the language and all agreed that the language doesn't say that. The language just says fabricators. So every window company, every curtain wall company, every panelized wall manufacturer, every through wall HVAC manufacturer, PTAC, needs to look at these requirements and say, are we going to become an approved manufacturer, or are we going to be subject to continuous inspections in our plant? Because that's what's coming, because people realize that this has been an issue. And if you're not a pre-approved fabricator, meaning you have a quality control program, you do your own quality inspections, you log those quality inspections, you keep records appropriately, all the things that a special inspection company has to go through, but applied to a manufacturer, are going to be required, along with someone certifying that they have it all and that it's up to date and current with yearly inspections of that stuff. That's coming 100%. And I think people in the fenestration field need to wake up to the fact that it's coming. It may start in New York, but it will spread from New York. And hopefully it doesn't get watered down. I'm making it my project to come up with more of a stricter requirement for how this needs to be done, a backbone for it, because just putting it in the code, it doesn't work, right? The biggest company around will come up with a certification program like they did for special inspection agencies. And at the beginning, it was great. And now it's just become fill out the forms, take the test, pay your premium every year, and you're a special inspection agency.
Well, I don't want everybody to just think I'm talking about air and water here too. We're talking about life safety or structural implications.
Absolutely. Absolutely. nothing's more life safety than an embed holding up a 1,000-pound piece of glass and aluminum or stone on a building.
Absolutely, absolutely. Adrian, we've been involved in quality testing and vetting out of fabricators in the past, and we've seen it go both ways. If there's a 50-50 breakdown, we see sometimes that 50% of the fabricators we work with are prepared. They're ready. They're on top of it. And then there are others that find that either because a project is new or because they are under different constraints, that there are a whole series of things that need to be checked. And it does become difficult to be in somebody's fabrication shop telling them how to do what they say they already know how to do. It can be
Not
awkward,
well received at all.
not well received. The first time you visit, you know, people buy you lunch.
carpet.
The fifth time
Yeah,
you visit,
red
they don't
carpet
even
gets
open the
rolled
door.
out.
They don't know you're there. They're even there. I think that, you know, Elliot's saying these days are coming. I think these days are coming, whether it's a cycle or whether it's something that's inevitable. For each project, not just the entire industry, these things come. And it goes back to the statement I made before: you pay now or you pay later. And I think there's a sort of approach to projects, whether they're bespoke projects or whether they're run-of-the-mill projects, where you can't let down the vigilance, having the right team, and having the right team do the right things at the right times. That's what makes a project successful. That's where people make buildings, and buildings don't make themselves despite the people involved.
That's a good one, Russ. People make buildings. Buildings don't make themselves.
I was just gonna say, I want to end on that note because that was awesome. There's your clip. So thank you guys. That was fun and engaging, and yeah, I'd love to do it again.
Sorry about the technical difficulties.
Yeah, we'll blame it on the chickens.
Oh, the battery on my laptop must be gone.
Thank you both. Have a
Thanks,
good time.
Guys.
Take care. Bye.
Bye, everyone.